The world has seen the wonder of dwarf planets in all their glory, and the uniqueness of these planets makes them a center of attention to this day. Over the past decades, astronomers have extensively researched our galaxy and its components. The discoveries made by scientists on their research journey have catapulted their analysis and observations of the planets around us as we discover new things every day about them and their peculiarities too. From the discovery of planets that have the potential to serve as habitats for life to thrive to the empty planets, the list is endless. These dwarf planets have been a mystery to researchers right from when scientists found them far away in the outer parts of our solar system. Their locations are in the deep parts of space, so these planets are relatively small and cold. Because of their distance from our planet Earth, it is very hard for astronomers to detect and observe them even when large telescopes are used. This is why only a few of them have been discovered across the solar system over the past years. In order to study these distant worlds effectively, scientists have been combing data from various sites of observation, and in the process, a massive structure was discovered. What is this massive structure? What does it contain? And how would this massive size affect our solar system? Join us as we explore the discovery of this massive planet that has been hiding in our solar system. The shocking discovery of 2007 OR-10 in the trans-Neptunian region was an addition to the mysterious bunch of dwarf planets. Thanks to the Kepler Space Telescope and the Herschel Observatory, it was examined further and more research was made on the dwarf planet. These findings brought out the results about the planet, and it turned out to be that 2007 OR-10 was the largest world with no name in the solar system. Of all the dwarf planets, the planet happens to be the third biggest in size. Contrary to results of previous research done, this shows that the planet is bigger than what it was perceived to be. Further reports were made on the planet as it was found to be quite dark and that it rotates more slowly than any other body that orbits the Sun, as it takes close to 45 hours to complete one rotation. The Kepler Space Telescope, which is now known as K2, was a major contributor to the analyzing and observations of this planet, together with the data obtained from the archives in the infrared Herschel Space Observatory, a research scientist that was based on the Kepler mission at NASA's Ames Research Center in California's Silicon Valley, here at Berenstain, commended the K2 by saying that the Space Telescope made a groundbreaking contribution when the study got to the stage of revising the estimated size of 2007 OR-10. The measurement of the planet's diameter was revised to 1,535 kilometers and is about 60 miles greater than the largest dwarf planet after it, planet Makemake, or about 3 times smaller than Pluto. Still, the astonishing part is how the combination of both Herschel and the Kepler Space Telescope brought forth such valuable information about the object's physical properties to aid the research. When compared with another dwarf planet, Haumea, it has an oblong shape that was wider on its long axis than 2007 OR-10, but when they analyzed the overall volume to 2007 OR-10, it turned out to be smaller. Although attempting to get the size of small and faint objects distant from the Earth can be tricky, since these objects appear from afar as mere points of light, it is not an easy feat to determine if the light coming from these objects represents a smaller and brighter object, or if it is a larger and darker one. These factors are what make the observation of 2007 OR-10 a complex task. Even though its elliptical orbit brings it close to the Sun, just like Neptune, it is still double the distance from the Sun to Pluto. When more data was obtained by researchers Brown, Burgas, and Fraser, the planet exhibited infrared signatures of both water ice and methane. Also, the appearance of the dwarf planet is quite reddish. The cause of this is believed to be due to tholins showing up on the surface ice, which happens due to the irradiation of methane by ultraviolet radiation. The presence of red methane frost on the planet's surface is also seen as an existence of a tenuous methane atmosphere, which would slowly evaporate into space when the planet is closer to the Sun. Although the planet comes closer to the Sun, its large mass maintains the methane atmosphere. The presence of water on the planet's surface suggests there must have been an icy volcanic eruption at a particular period, also known as cryovolcanism. According to Brown, the period is not the cause of water ice freezing on the surface, but the creation of the nitrogen and carbon monoxide atmosphere. All of these factors should have diminished quickly, and only a fragile atmosphere of methane would be the only thing left today. However, more data has to be gathered before astronomers can conclude whether or not 2007 OR-10 has ever had a history of cryovolcanism, an atmosphere, or even what the planet's interior looks like. Our revised larger size for 2007 OR10 makes it increasingly likely the planet is covered in volatile ices of methane, carbon monoxide, and nitrogen, which would be easily lost to space by a smaller object, said Andras Pell at Congahe Observatory in Budapest, Hungary, who led the research. It's thrilling to tease out details like this about a distant new world, especially since it has such an exceptionally dark and reddish surface for its size. The 2007 OR10 later got renamed to be referred to as Gonggong, and as the researchers kept moving forward in their study, an amazing discovery was made: the Kepler-78b, also known as the planet that shouldn't exist. This planet remains a mystery to scientists today as it has slight components in relation to Earth's composition and size. It is a planet with a superlight orbit, is just 20% more massive than Earth, and even possesses the same density as Earth. In simpler terms, the Kepler-78b can easily pass as Earth's twin. The temperature on this planet ranges from 2,240 to nearly 5,000 degrees Fahrenheit, and judging from this, you can say that this planet is a planet of lava. The burning world moves around its parent star very fast, completing its yearly orbit around the Sun within 8.5 hours. This exoplanet was found around a star called Kepler-78 that stays about 400 light-years away from Earth, and scientists refer to it as an alien planet because nobody knows how it got there. Astronomers discovered the world of lava by watching the star dim a little bit just as the exoplanet passed in front of the star, blocking its light. And because it orbits so close, a different set of measurements was used to calculate the amount of gravitational pull the planet exerts on its parent star. Altogether, this collation of this data allowed the scientists to calculate the planet's mass and density, which resulted in 5.57 grams per centimeter cubed, the same density as our world. This concludes that Kepler-78b is a rocky planet and one of the planets in familiar compositions just like planet Earth. Another mystery about this massive planet that baffles astronomers is that the Kepler-78b orbits really close to its parent star. According to current theories surrounding planet formation, no world is meant to form successfully at such a close distance. But scientists and astronomers keep discovering surprising mysteries about the hundreds of newly discovered exoplanets and other star systems. They feel that their theories on planet formation are probably wrong. However, there are also opinions that the planet's days are numbered. This is said because the planet would continue to orbit nearer and nearer until the gravity coming from its parent star tears it apart. This is predicted to happen in the next 30 billion years. The planet was spotted through the use of the National Aeronautics and Space Administration's Kepler Space Telescope, one of the major machines that are always used when on a mission to search for exoplanets. And this space telescope has successfully discovered more than 130 other worlds. However, the Kepler Space Telescope recently had a mechanical failure that has put it out of commission. So while you might say that the planet-hunting days are probably over for the glorious machine, scientists are still trying to find a way around it to see if the mission can be used for other purposes. The exploration done in our solar system has made us understand the universe and its entirety, from the unique galaxies to several unimaginable planets that have orbited our solar system. And when we think about life out in space, we think about what life in the rocky and very hot world of Kepler-78b will be like, even though life on this planet might be the direct opposite of ours. Exploring the final frontier of the possibility of new phenomena has been fruitful over the years, with some leading to the discovery of planets surrounding our solar system. However, some of these discovered planets were later deemed dwarf planets, one of which is Pluto. Ever since Pluto became catalogued as a dwarf planet, scientists had only 8 planets recognized as of 2005. Since then, they continued their exploration in space, making new inventions and using them to make remarkable discoveries. This led to the detection of Eris. Eris was discovered in 2005 during a Palomar Observatory survey of the outer solar system. The survey was conducted by astronomers Mike Brown from Caltech, Chad Trujillo from the Gemini Observatory, and David Rabinowitz from Yale University. Spotted at the solar system's edge, Eris is a trans-Neptunian object and a member of a high-eccentricity population known as the scattered disk. It orbits our Sun at a distance of 96.4 astronomical units, making it the farthest object except for some comets. It was discovered by the data obtained from the Palomar Observatory survey in 2003, but wasn't noticed immediately. Upon discovery, it was nicknamed Xena until its name was changed after the Greek goddess of discord and strife, Eris. This name holds meaning as it caused several scientific disagreements and controversies. Astronomer Mike Brown explained the circumstances behind the planet's name, saying, "Eris is a goddess that stirs up jealousy and envy to create fighting and anger among men. One such example was at the wedding of Peleus and Thetis, where all the gods were invited with the exception of Eris. When she learned about her exclusion from the gathering, she spitefully caused a quarrel among the goddesses that led to the Trojan War." This name fits as the discovery of Eris was one major factor that led to the demotion of Pluto from being part of the 9 planets in our solar system and cataloging it as a dwarf planet. According to Govert Schilling, a Dutch astronomer and science writer, he said Brown initially planned on calling the dwarf planet Lila. He chose Lila after a concept in Hindu mythology that described the cosmos as the outcome of a game played by Brahma. Also, it was very similar to Brown's newborn daughter's name at the time, Lila. Brown also had options for other names such as Persephone, the wife of the god Pluto. Eventually, it could not work as an asteroid had already been named 399 Persephone, so that ruled that name out. With no other options, the Discovery team sent in Eris on September 6, 2006, and the IAU approved it as the planet's official name on September 13th. This name was peculiar to Brown for 3 reasons. 1, Eris had been regarded as a planet for so long, which assured him and his team that it deserved a name from Roman or Greek mythology like the others. 2nd, Eris was Brown's favorite goddess. 3rd, the name has not been used in the Greco-Roman pantheon that had been assigned to asteroids in the solar system, so it sounded like a perfect fit. Although finding out details about Eris was a bit difficult as it was so far from the Sun, determined scientists found a way by using a celestial alignment known as occultation. Bruno Siccardi, a scientist from the Paris Observatory, and his team began by calculating the diameter of Eris in 2010. The occultation happened as a result of Eris moving past a background star, therefore blocking the star's light and casting a small shadow on Earth. When the team analyzed the shadow size in Chile at 2 separate sites, both calculations gave a diameter of 2,326 kilometers for Eris. Before the 2010 Eris study, Siccardi conducted research on Pluto in 2009, and the outcome placed its diameter at least 2,338 kilometers. When Eris was initially discovered, the first estimates about the dwarf planet's size placed its diameter at 3,000 kilometers, but that wasn't the only outcome scientists relied on. In 2006, the Hubble Space Telescope joined with the Keck Observatory telescopes in Hawaii to measure the dwarf planet again. Its observation showed that Eris is slightly larger than Pluto, with a diameter of 2,400 kilometers. Achieving this measurement was quite difficult because for most telescopes the planet is very small and could only be identified as a dot of light. To get the measurements, the scientists working on the study waited until Eris was close to a star, then took 28 pictures of the planet. These photos were analyzed thoroughly by comparing the star and the planet, and eventually the Hubble Space Telescope came up with the answer. While learning about the dwarf planet, scientists made findings to see what was on the planet's surface. To do this, they studied the composition of far-off objects by looking at the sunlight reflected off them. For example, when the sunlight reflected off the Earth's surface is studied, it shows evident signatures of the oxygen in Earth's atmosphere, abundant water, photosynthetic plants, and other distinct features. Scientists used the Gemini Observatory on Mauna Kea, Hawaii, to study the light reflected from Eris's surface, and they saw that the planet looked very similar to Pluto. Eris's surface was very reflective, bouncing back 96% of the light that hit it. This makes the dwarf planet one of the most reflective bodies in the solar system, roughly similar to Saturn's moon Enceladus. Speaking of moons, a moon was spotted in orbit around Eris on September 10, 2005. It was discovered by a group of scientists with the Keck telescopes in Hawaii while observing the 4 trans-Neptunian objects: Pluto, Makemake, Haumea, and of course Eris. When the moon was discovered, it still had the nickname Xena, named after a warrior princess in a TV show. Scientists and astronomers believe that Eris's surface is likely to comprise a piece of nitrogen-rich ice mixed with frozen methane in a layer less than 1 millimeter thick. This layer could result from the dwarf planet's atmosphere condensing as frost on the planet's surface occasionally as it moves away from the sun. The new observations also allow researchers to make new calculations for the dwarf planet's surface temperature. Their study showed that the part of Eris which faces the Sun is likely to get no warmer than minus 396 degrees Fahrenheit, while temperatures on the night side would be even lower. Although Eris has similar features to Pluto, they are not completely identical. Apart from their larger size, there are more ways in which these two planets have differences. For example, their surfaces. While Eris's surface appears almost white, Pluto's surface depicts a moderate red. Also, Pluto has a mottled-looking surface that reflects 60% of the sunlight that hits it on average. On the other hand, Eris has a different look and reflects differently. It appears uniform and reflects about 86% of the light that hits it. A fun fact about the characteristics of these planets is that they are not similar. As a matter of fact, Eris reflects the most sunlight from its surface compared to any planet or object in the solar system other than Saturn's moon Enceladus. This is because Enceladus has active geysers which coat its surface continuously with fresh frost. Considering all these, scientists could not think of any source of heat for Eris that could bring about small geysers. So how is it able to reflect so much light? After continuous research, they propose that Eris's bright surface and the uniform coloring of the planet are most likely the cause. As of this moment, the dwarf planet is as far away from the Sun as it ever gets, making it extremely cold. With this distance from the Sun, the planet's atmosphere is frozen solid. If Earth happens to move that far away from the Sun, our planet's atmosphere will freeze up too. Scientists also propose that in 280 years, the planet would be at its closest, which would be a factor of almost 2.6 times closer. Also, the overall temperature on the planet would increase in the next 280 years by a factor of 1.6. In summary, the hypothesis by scientists says that Eris is bright and uniform due to its previous atmosphere, which had been frozen to the ground about 280 years ago. Scientists say this gives a bright, glistening coating to any previous form of mottled surface. Also, this freezing process is said to happen repeatedly with the planet's orbital period, which happens over 580 years. It is a reason why the whole atmosphere is probably only a few inches thick. Eris's far-off distance, along with its small size, is why it is difficult to observe the planet effectively without advanced technology. Presently, there are no plans of sending any spacecraft to fly by Eris soon, but powerful telescopes like the James Webb Telescope will be used for the task. As a matter of fact, the James Webb Telescope website picks Eris as one of its objectives and would also observe smaller objects in the solar system to see what their landscapes are made of. The mystery surrounding Pluto presented misinformation in elementary education about one of the other 8 worlds where aliens probably existed far away in the universe. Much of that pile of junk information has been debunked, and the much maligned Pluto didn't exactly vanish into the thinnest of air. But what happened to Pluto? And since its rediscovery, what have scientists discovered? Pluto is still currently not considered a part of our solar system, but is now categorized as one of 5 dwarf planets in our solar system. They are primarily spherical and, without consideration for size, could very well get the planetary bodies in our solar system numbering up to 13. But the 5 dwarf planets make up what is known as the Kuiper Belt. Pluto is not called the icy planet for any reason other than the fact that it's made up of methane, frozen nitrogen, and an unhealthy amount of carbon monoxide ice. Much like some parts of the Earth, the smaller planet has its own polar caps accumulated due to the frozen nitrogen and methane. However, it still retains its famous moons, Charon, Hydra, Kerberos, Styx, and Nix, of which the biggest is Charon. The peculiar positioning of the moons means they always face each other. These were pre-disappearance information widely known about the dwarf planet. Still, scientists have made more progress in the last 16 years with relatively new information about the nature of the Plutonian ball. NASA's first significant observation of Pluto since its demotion took place in 2006 to 2007 happened when NASA's New Horizons spacecraft was launched towards the far reaches of Jupiter. However, the spacecraft's primary mission had nothing to do with Pluto. It was sent to test the gravity boost and make a few more scientific observations. That same spacecraft maintained a routine flyby reconnaissance of the dwarf planet and its moons 8 years later, on the 15th of July 2015. It seemed like checking out Pluto was merely one of the spacecraft's side missions on its way to discovering other icy planets that existed a billion miles further from Neptune to orbit. The drive-by wasn't without some results as we gained a clear view of what Pluto now looks like. We saw much beyond its blue tint and a distinct layer of haze, a stern reminder that it's the coldest planet out there and can never entertain human life. Before the expedition, we knew too little about it, not even its size or how it was on the inside. The New Horizon probe helped scientists calculate the exact diameter of the planet, 1,476.8 miles, which when converted is just about 2,376.6 kilometers. Weighing it up against the Earth, it is but 1/5 the entire size of the Earth and not anywhere near the size of our Moon. And for the first time, we actually got to know what some of Pluto's surface features look like. Pluto has ice-capped mountain ranges that stand tall at about 11,000 feet. That's just as tall as the Rocky Mountains on Earth. There arose a dispute about the veracity of the perceived mountainous features. Scientists argued that much of Pluto's surface is covered by nitrogen, ice, and methane, and that they do not think that the ice can support an enormous peak. However, it cannot be discredited that actual mountains were seen. This meant the mountains might be formed on a much stronger foundation known as water ice. A nice theory, but just how deep do these layers of water ice have to go to hold the mountains? Much of the ice caps are made up of methane ice, but further analysis by scientists has noted some unique traits in how the ice tends to reflect light on the surface of Pluto. It also seemed to resemble some of Earth's features, such as the penitentiae formed by erosion across the surface of the mountain terrain. The clear difference is that these terrains seem larger than Earth at 1,650 feet in height compared to Earth's, which is only about a few meters in size. Pluto has its own series of amazing features that remain yet unexplored. A prime example is the Tombao Regio, the unofficial name given to the heart-shaped region observed on the surface of Pluto. A part of its landform is likened to an ice cream cone shape but is strictly covered by carbon monoxide ice. It's now iconically identified as the heart of Pluto. Right in the middle of the heart-shaped crater is another smooth region named Sputnik Planum by the probe's team, a name it now shares with Earth's first artificial satellite. Meteorite impacts are known causes of craters in most planetary bodies, but the Sputnik Planum doesn't have such a deformation. According to the geological timescale, scientists deduced that it is a relatively young region and could be about 100 million years old. There are suggestions that it might be yet to attain its permanent shape as geological processes can continually change it. Much like the kind of streaks you can often see in Earth's arid region, the scientists observed a series of dark streaks that appear to be a few miles long and going in the same direction on the surface of Pluto's icy plains. What could have caused this? Could it be the not-so-friendly winds that frequently blow across the planet's surface? Further research using NASA's Hubble telescope led to the idea that the planet's surface crust could be composed of complex organic molecules. The telescope also identifies that the planet appears redder than it used to be due to its seasonal changes. Concerning some of its natural landforms, it is possible that the planet used to have a subsurface ocean, or maybe it still does. And when we think of that, it could mean that everything we know and think of the planet could be entirely debunked, especially considering its potential to host human life. Pluto has always been easily disorientated due to its ice population, concentrated in a region like the Sputnik Planum, where the ice is about 10 kilometers thick and goes as far as 6 miles. This is one of the reasons why they considered the existence of a subsurface ocean amidst other less likely scenarios. If the ocean was always moving and freezing in place, it could often displace the positioning of the planet. A few of its orbital characteristics point to the fact that its orbital range is estimated to be about 49 times further from the Sun than Earth is. Its orbit is not exactly circular either, and thus could mean that its distance from the Sun varies depending on its position. It's accepted that at some point in its revolution, it tends to be closer to the Sun than Neptune for about 20 years. And according to Earth's timing, the planet takes about 248 years to orbit the Sun. It spends 228 more years further away than its closest companion, Neptune. It was during one of such further drifts that it got demoted from its rank as the 9th observable planet in our solar system. If it did ever get close enough to the Sun, much of the surface ice would eventually thaw, and its atmospheric layers would be at their thinnest, lacking much of its carbon monoxide ice, but mostly retaining its nitrogen and a little bit of methane. At that point, scientists might consider Pluto to be in its most habitable form. although we have no idea what to do about its low gravity, which is about 1/20th of the Earth's. Hence, its atmosphere appears much denser and higher than Earth's, and the further it strays away from the Sun, the denser it becomes as the atmosphere freezes until it phases out of view. When considered at its thinnest, scientists have surmised that it restricts the flow of fluids. One proof of this is provided by the New Horizons in an image of a frozen lake in the Tombau Regio. They also saw what looked like water channels. We join them in thinking about the possibility of the planet having an atmosphere 40 times denser than the red planet, talking about Mars, of course. There were also observations of certain cloud forms in the atmosphere. The clouds were formed at low altitudes with technically the same sizes, but the major components of these clouds are thought to include acetylene, ethane, and hydrogen cyanide. Did you also know that the dwarf planet spins back from east to west, which opposes everything that makes up the characteristics of the major planets in our solar system? There's a lot of information waiting to be discovered about the planet. NASA's New Horizons mission is the only mission dedicated to observing Pluto, its moons, and every other world that may exist beyond it in the Kuiper Belt. Not knowing much about the planet means we don't know if the probe will survive the harsh environment that awaits it beyond Pluto's orbit. The fact it already has 5 moons as satellites has not done much justice to easing fears that the spacecraft could collide with debris or undiscovered moons and eventually be crushed under their weight. For now, we expect it to show us more up-close images of Pluto as we anticipate a better understanding of what thrives on Pluto. Let us know what you think about these discoveries on Pluto in the comments section below.